Okay, so question 18, determine the area of the largest rectangle that has one side on the x-axis and two vertices on the curve. So what that's trying to tell you is that you're constructing a rectangle that's going to be touching 2 points on this equation. Now, because it's a rectangle, that means that those 2 points have to be in the same spot. So our rectangle could look something like this. So if I just chuck a little point in there, whee, like that. Now, one thing that I'm going to consider at the moment that it hasn't asked me to do, but otherwise it might cause problems for me later, is I'm going to think about the domain. Now, if I'm constructing a rectangle here and I'm thinking about creating an expression for the area is equal to length times width. So here is our x values on the bottom, which means that our x value, if I take this point here as, 0, and I go this side, that's going to be one set of whatever x we decide is the best. On the other side, it's going to be another x. So that means that this thing is going to have a width. No, we'll call it length. We'll call it length of 2x. So from here to here, that is 2 lots of the x, and our width is going to be based on whatever this point is. Now, you can see that this point relates back to our y coordinate given x. So our width is going to be e minus x squared, and we'll substitute in whatever value we decide as x so that we can find out what that is up here as our y coordinate so that we've got the height of this thing. So that means that the expression for our area is going to be given by 2x times e minus x squared. Now, thinking about the problem, you can see that we've got some sort of intercept just past where x is equal to -2, unless that is an asymptote. But it really doesn't make sense for this thing to go past these points. So while I don't know for sure if it's got an asymptote at the moment, I can say that it can't be smaller or touching 0. So if x is 0, then this whole expression is 0, which means it has no area. All the way up to infinity, assuming that this thing doesn't have an asymptote. But it really doesn't make sense for it to be that small because then we're not going to have any area. Okay, so maybe let's start writing in black like a normal person. All right, so I have sketched the equation over here in my graphics calculator. We're going to look at the expression for the area and what that graph looks like. Now, this is tech-free, so you won't be able to do this. This is solely for understanding. So if I press execute and I draw this thing, now I'm going to go zoom. I'm just going to let this thing auto-zoom. Okay, and now I am just going to adjust my view window because this thing isn't giving me quite what I want. Let's just make it a square. Nope, that's made it worse. View window, standard, draw. All right, live with that. Okay, so this is the expression for the area. So when x is 0, the whole thing is 0. It doesn't make sense for it to be anything in the negative quadrant because that would essentially mean that it's eating into itself. Now, it does make sense for it to be in our positive quadrant, and we obviously want it to be at its maximum point because that's when we have the most area. So if this was calculator allowed, I could G-solve straight away to get the max. Boom, there it is. But we can't do that. So even though I can see where it is, the other thing that I can see is that here it's going to be 0, so it's not down at 0. There, when x is that's my max, and then it goes back down over here. So if we're talking about what this is in terms of derivatives, it's when we're looking for a stationary point. So we now want to determine a dash when that is equal to 0, and then that will give us the x coordinate where our function is at a max. Now, once we've done that, we can find the area by getting our x coordinate from here and putting it back into that expression. Okay, so we're going to have to use product rule to do this. So A dash is going to be equal to U times V dash plus V times U dash. So U is going to be equal to 2x, which means U dash is equal to 2. V is going to be equal to e to the power of negative x squared, which means V dash is equal to, derivative of this top section will be minus 2x. Yep. And we have E, and then that won't change. Okay, so now I can chuck this into product rule. A dash is equal to 2x bracket E minus x squared bracket. Wait, nope, stuff that up. Whee! Okay, minus 2x E minus x squared bracket plus E minus x squared times 2. If I do these two multiplying each other, I'll end up with minus 4x squared E minus x squared plus 2E minus x squared. Now, like we did before, we're going to be letting this thing equal 0 because we want to find the stationary point. So from here, this is just going to be a little bit of a trick about factorising things out. Now, I can see that they both share this as a factor. So that can come out, and I can see that they've both got 2 because that can be divided by 2 as well. So that's what I'm going to take out the front. So 2e minus x squared bracket. When I divide this by that, I'm going to end up with minus 2x squared plus 1 equals 0. From this point, I can now use null factor rule to determine our coordinates of the stationary points. Now, it's going to give me 2 because it's going to give me the minimum on this side and the maximum on that side. Identifying my domain means that I won't have to test for which stationary point will give me the maximum. I can disclude the other one straight away. But if you don't test or state the domain, then you should be discluding one of them based on which one gives you a positive or a negative. You test the points around it or you use the second derivative to test. So 0 equals 2 minus, come on pen, e minus x squared. Take the 2 across, 0 divided by 2 is just 0. E minus x squared, if I take e across to the other side, becomes ln of 0 equals negative x squared. Now that can't happen, that gives me a math error. There is no value that you can substitute in up here to make that statement 0. If I put in a 0, it'll become 1. If I put in 1, it'll become some sort of really small number. And if I put in a negative number, then it'll become a really big number because this negative at the front, oh no, it won't. It'll still be a very small number. So this is a math error. Okay, next one we want to test for. So 0 equals bracket minus 2x squared plus 1. First thing I'm going to do is take the 1 across to make the negative 1. Then I'll divide it by a negative 2. I'll be left with x squared on this side. These two negatives will cancel out, so now I'm testing for this. Take the squared across by square rooting that equals x, and anytime I take the square root, there is a plus or a minus involved. Now, we can already say, so negative solution is not in the domain, which means that x must be equal to square root of a half. So next thing we have to do, because it's asking us to calculate the area. Now I'm just going to sneak this last bit in at the top up here. So area is equal to, and I'm going to use this as my x value. So 2 times 1 over root 2, or you could say the whole thing is still in a fraction. But square root of 1 is just 1. Square root of 2, we'll leave it like 2. Obviously that's not rationalised. 1 over root 2 squared like that. Okay, so then I'll have 2 over root 2 e to the power of negative. So this power will come in and multiply that 1. 1 squared is just 1. This will come in and multiply that one, meaning it will just remain as e to the power of negative a half. Okay, and last part, I'm not sure if you get marked down in methods for not rationalizing the denominator, but definitely in specialist. So the last thing that I would do is I would represent this by multiplying the top and the bottom of this by root 2 so that this gets rationalized. So this is going to become 2 root 2 over 2, meaning that they will cancel out. E to the power of negative a half, or I could say that it becomes root 2 over e to the power of root. No, I'm just going to express that as a half. E to the power of a half. And then that'll be my final answer. Now, if I wanted to test if this was tech active, all I'd have to do is chuck this back into a calculator and I would be testing that the area, or that this expression here, no, that's the area. If I wanted to test it, I would chuck this back in, square root of a half, and make sure that that is in fact equal to 0.707. So I'm going to do that in the calc section. Obviously, if this is incorrect, you'll never see this video again. Shift square root 1 divided by 2, execute, root 212, F to D, boom, and we got the right answer.